Hello everyone, welcome to this video. In this video they are asking us this question that if a1, a2 up to an they belong to any group G, right? So what is the inverse of this element when multiplied together, a1 into a2 into a3 and so on up to an? So let's have a look at the solution. It's also very simple solution. So we first of all assume that let G be a group, right, which is given to us, and then we assume that a1, a2, a3 up to an they all belongs to G, right? So we know if we have AB whole inverse, this is equals to B inverse A inverse, and this is the well known sock-shoe property, correct? So using this property, we'll make use of this property in order to prove our result. So we will prove our result by the principle of mathematical induction. To prove that a1, a2 up to an whole inverse, this is equal to an whole inverse, an minus 1 whole inverse, and so on up to a1 whole inverse, correct? So we need to prove this thing. So when we wanted to prove this thing, let's first of all prove it for in the case 1, we let n is equals to 1 and we will prove the result for it. So for n is equals to 1, our left hand side would become just a1, right? a1 whole inverse. And what is your, so this is just a1 inverse, right? And your right hand side would become, again it is a1 inverse. So you see both are same, hence the result is true. Hence the result is true for n is equals to 1, right? In the second part, we assume that, so we assume that the result is true for n is equals to k. So what does it mean? It means that if we go up to the element ak and then calculate the inverse of whole thing, it would be equal to the inverse of ak, the inverse of ak minus 1 up to the inverse of ak. Let's mark this as equation 1, right? We'll make use of this in order to prove the result for n is equal to k plus 1. So let n is equals to k plus 1. So in this case, we will prove that a1, a2 up to how much? ak plus 1 whole inverse, that is equal to ak plus 1 inverse, ak inverse, and so on up to a1 inverse, right? We wanted to prove this thing. Let's mark this as equation number 2. So we first of all consider the left hand side here, right? What is your left hand side? It is a1, a2 up to ak plus 1 whole inverse. So here you can write this as using the property of associativity up to ak in one bracket and then ak plus 1 in another bracket, right? This thing is using associativity. So once you have applied this thing, now here we can apply sock-shoe property in order to have a k plus 1 inverse and then a1, a2 up to ak whole inverse. This is by sock-shoe property, because that can be applied on to two elements of the group. Now here ak plus 1 inverse is as such. Here we can make use of equation 1 in order to have ak inverse, ak minus 1 inverse, and so on up to a1 inverse, right? This is using equation 1, correct? So once you open up the brackets, it would be a k plus 1 inverse, a k inverse, and so on up to a1 inverse. And what is this? This is your right hand side. Hence we have a1, a2 up to an whole inverse is equals to an inverse, an minus 1 inverse up to a1 inverse, this thing for all natural numbers n. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.